everyone, I am Anila Argauda, an electronic and communication engineering student studying at Sri Venkateswara College of Engineering. Today I am going to give presentation on types of solar cell material. So these are the five types of solar cell material. First one is amorphous silicon, second one is quantum dot solar cell, third one is dye sensitized solar cell, fourth one is monocrystalline silicon, and fifth one is polycrystalline silicon. First we will go to the amorphous silicon. Amorphous silicon is the non-crystalline form of the silicon used for solar cells and thin film transistor in LCDs. As a second generation thin film solar cell technology, amorphous silicon was once expected to become a major contributor in the fast growing worldwide photovoltaic market, but has since lost its significance due to strong competition from conventional crystalline silicon cells and other thin film technologies such as CDTs and CIGS. Amorphous silicon is a preferred material for thin film transistor like TFTs, elements of liquid crystal displays LCDs, and for X-rays images. Amorphous silicons are generally features low efficiency and it is used as semiconductor material for thin film silicon solar cell. It is deposited in thin films into a variety of flexible substrates such as glass, metal, and plastics. Amorphous silicon differs from other allotropic variations such as monocrystalline silicon, a single crystal, and a polycrystalline silicons that consist of small grains and also known as crystallites. One further advantage is that amorphous silicon can be deposited at very low temperature, example as low as 75 degrees Celsius. This allows deposition on not only glass but on plastics or even on a paper substrates as well, making it a candidate for a roll-to-roll processing technique. Once deposited, a silicon can be doped in a fashion similar to SSCI to form p-type or n-type layers and ultimately to form electronic devices. So this is the diagram representing the amorphous silicon. The above are the solar panels and the below is showing the calculator display. The next type of solar cell is quantum dot solar cell. A quantum dot solar cell is a solar cell design that uses quantum as the absorbing photovoltaic material. Here, as of 2022, efficiency exceeds 18.1%. Quantum dot solar cells have the potential to increase the maximum attainable thermodynamic conversion efficiency of solar photon conversion up to about 66% by utilizing hot photo-generated carriers. In a conventional solar cell, a light is absorbed by a semiconductor producing an electron-hole pair. The pair may be the bond, it's referred to as an excision. This pair is separated by an internal electrochemical potentials. And the resulting flow of electrons and holes create an electric current. The internal electrochemical potential is created by doping one part of the semiconductor interface with atom that acts as electron donors, N-type doping, and another with the electron acceptors, p-type doping. Quantum dots have band gaps that are tunable across a wide range of energy levels by changing their size. In bulk materials, the band gap is fixed by the choice of the materials. This property makes quantum dot attractive for multi-junction solar cells, whereas a variety of materials are used to improve efficiency by harvesting multiple portions of solar spectrums. In this diagram represents the spin quantum dot solar cell built in by the Saragen group at the University of Toronto. The metal disc on the front surface are the electrical connections to the top layers below. The third type of solar cell is dye-sensitized solar cell. A dye-sensitized solar cell is a low-cost solar cell belonging to the group of the thin film solar cell. It is based on a semiconductor formed between a photosensitized anode and an electrolyte, a photoelectrochemical system. The DSSC has a number of attractive features. It is simple to make using conventional roll printing techniques. Is semi-flexible and semi-transparent, which offers a variety of uses not applicable to glass-based systems. And most of the materials used are low cost. In practice, it has proven difficult to eliminate a number of expensive materials, notably platinum and ruthenium. And the liquid electrolyte presents a serious challenge to making a cell suitable for use in all weather. Although its conversion efficiency is less than the best thin film cells, in theory its price performance ratio should be good enough to allow them to compete with fossil fuel electrical generation by achieving grid parity. Commercial applications which were held up due to chemical stability problems had been forecast in the European Union photovoltaic roadmap to significantly contribute to renewable electricity generation by 2020. So this is the diagram representing the dye-sensitized solar cell. The fourth type of solar cell is monocrystalline silicon solar cell. Monocrystalline refers to mono means single. So monocrystalline silicon refers to single crystal silicon. Is the base material for silicon-based discrete components and integrated circuits in virtually all modern electronic equipment. Monosilicon serves as photovoltaic light-absorbing material in the manufacture of the solar cell. It consists of silicon in which the crystal lattice of the entire solid is continuous, unbroken to its edges and free of any grain boundaries that are single crystals. Monosilicon can be prepared as intrinsic semiconductor that consists only of exceedingly pure silicon, or it can be doped by the addition of other elements such as boron or phosphorus to make p-type or n-type silicon. Due to its semiconducting properties, silicon crystal silicon is perhaps the most important technological material of the last few decades, the silicon era, because its availability at an affordable cost has been essentially for the development of the electronic devices on which the present day electronics and IT revolution is based. Monocrystalline silicon offers from other allotropic forms such as non-crystalline amorphous silicon used in thin film solar cells and polycrystalline silicons which consist of small crystal known as crystallites. So this diagram represents the monocrystalline silicons. The last type of solar cell is polycrystalline silicon. Poly is nothing but more or many. Polycrystalline silicon or multicrystalline silicon, also called as polysilicon, is a high purity polycrystalline form of silicon used as a raw material by the solar, photovoltaic and electronic industry. Polysilicon is produced from the metallurgical grade silicon by a chemical purification process called Siemens process. This process involves desalination of volatile silicon compounds and their decomposition into silicon at high temperatures. An emerging alternative process of refinement uses a fluidized bed reactor. The photovoltaic industry also produces upgraded metallurgical grade silicon using metallurgical instead of chemical purification process. When produced for the electronic industries, polysilicon contains impurity levels of less than 1 part per cent, while polycrystalline solar grade silicon is generally less pure. A few companies from China, Germany, Japan, Korea, and the United States, such as GCL Poly, Wacker, Tokyoma, OCI, and Semiconductors, as well as the Norwegian headquartered REC, accounted for the most of the worldwide production of about 2 lakh to 30,000 tons in 2013. The polysilicon feedstock, large rods usually broken into chunks of species, sizes and packaged in clean rooms before shipment, is directly cast into multicrystalline ingots or submitted to a recrystallization process to grow single crystal balls. The balls are then sliced into thin silicon wafers and used for the production of solar cells, integrated circuits, and other semiconductor devices. So this is an example for polycrystalline solar cell. Thank you for watching my video. Please subscribe, share and like.